Dus dat is een oscillating stator, een oscillating stator. Rotation by oscillation. Oscillation by rotation.
Heb je het?
Ja, en nou probeer het nou nog eens. Try again.
Doesn't work.
Oké. En nou nog een keertje. Oké, doe maar. So it's a matter of balance. The top is a bit heavier than the bottom, and the balancing is opposite of the upper and the lower one, and then it gives this oscillation. That's the latest discovery for IPMM number 14. We are going to implement this with the chakra disc.
It's very easy to hold it stable. It's not hard. It's just moving the middle diameter.
Probeer hem nou eens op de kop.
Oh ja.
So, upside down. It's the same thing but upside down.
That doesn't work.
Doesn't
If we
work.
put this on top. Oh, no. More or less the same.
So the top portion has to be a bit heavier than the lower portion, but not too much. Otherwise you get a too much oscillation. Just enough. Okay. That's the stator trial. Now we're going to make the machine. And this is in place of this thing. This was projected as a pendulum to give that oscillation, but it's too heavy and too complicated with all this flywheel under here just to drive the disc here. So this we're going to replace with that thing, and then we'll see if you have self-running capacity by oscillation. Welcome to the IPMM14. In this version we study the oscillator here on top, which makes which is not the pendulum but a different concept, more like Vinsrud, who has this ball running on a rail, and this has the same effect because if you flips the seesaw that is linked to the disc. So this is the test to involve gravity as an oscillator, also inspired by the Milkovic oscillator. First we try this one, and we'll give it a run now. As you can see, it follows closely. It has to be given some speed, and Okay, now it's up to speed. And let's see whether it maintains its rotation, if there's any sign of overunity in this. And well, it apparently has difficulties keeping the time, so to speak, translating the energy of time between magnetism and gravity. That's the basic idea. That's the thesis of the suggestion of Finrod. It's not a thesis. He's not a scientist. So we're looking for this balance between these forces. So it has to catch a rhythm. So it's, but it's still my my hand delivering the input. There is a mechanical logic to it, but it's not. This is not quite the balancing we were looking for. Maybe we can make this upper oscillator. Let's call it the rotational oscillator bigger, or I have to replace it with a pendulum again, which is a more complicated construction. So, well, this it's a nice design, but there's no sign of overunity. Apparently, that's a very delicate balance between forces, and it's not simply done with a feedback loop involving gravity and magnetism, because then it still behaves apparently like one and the same force. And well, we'll keep trying, and maybe someday we'll manage. But at least this is an idea to understand the rolling ball on the rails of Finrod. This type of balancing act is what he does. The ball throws the stator of balance that is running over a magnet field in Finrod's model. So if we can expand this, and then we would have to add levers to for an increased instability or unlikelihood of balance, which would be then the natural order. There's the unlikelihood of balance. There cannot be any balance in nature because it's a broken symmetry of forces. So yeah. Well, we don't see it happen yet. It's not that easy. But we made a nice discovery with this kind of oscillator, gravitational oscillator. So this can be fast and still be oscillating. And well, that's all I can say about it as yet. So this is IPMM14. I thank you for your attention.